Hello, and welcome to the second in the series of building better teams. We're going to give you a brief history on the science of team science, give you some insight into how this really kind of came about, and some of the ways that you can learn from this really fascinating field of research. This is part of a series that was hosted by IMOD in 2025, and we've adapted the slides and the presentation for online content. We recommend that folks bring a pen and paper. There are a couple of places where we ask folks to reflect, and this will help you think about how some of these things are connected to you. So, what do we mean by the science of teams? Well, ever since there's been teams, there's been people looking at ways of making it better. How do they perform better? The art of war is essentially a treatise on how teams can perform better. The same can be said for the organization of the Roman army. The way that they structured teams and gave structure and purpose was one of the reasons that it was such an effective force in Europe. Um, Moving rapidly to the modern day, something like the NASA Apollo moon missions is a great example of how teams come together, bringing together interdisciplinary expertise to really focus on a large problem and a large challenge. And something we're going to take a bit of a deeper dive into is the work done by teams from the NIH and the National Cancer Institute in the early part of this millennium that brought together interdisciplinary experts to really look at how to more effectively look at research into tobacco cessation and control of these substances. Essentially, everyone wants to know how to make a team more effective, and that's what the science of teams is about. So, why do we need team science? Well, this chap, Aristotle, was one of the first people to really start putting labels on disciplines within scientific research and sort of started to identify scientific disciplines. And this was a requirement for us to really take a deep dive into these spaces because as our scientific knowledge grew, no one person could be an expert in biology and in chemistry and in the natural world and in physics. And so having these delineations helped us really take some deep dives into expertise. But what that means is that the way we've divided up our universities, we've got colleges, we've got departments that end up being a little siloed. And that's not how the problems are. A lot of problems require input from biology, from chemistry, from physics, from engineering to solve it. And if we remain siloed, we're not going to come up with the solutions that we need. So this is where teams come in. The real goal of an effective and high performing team is that the whole is greater than the sum of its parts. We still need experts. You don't just get a group of generalists together and hope for the best. You need experts who can work together. So going back to the mountaineering metaphor that I put in the first session, if we just got a bunch of people, eight of people together who were kind of good at a bunch of stuff, we wouldn't get to the top. We need someone who's great at ice climbing. We need someone who's great at pitching on rock. We need someone who can carry stuff up. We need someone who can cook and keep people fed during the time. We need a whole range of people to really achieve the goals that we have with these higher term things. They do need to work together, and that's some of what we're going to talk about in this series. So I'm putting this in here because this is something that I found super interesting over the sort of essentially the last 2 decades is the emergence of the science of team science. And so, as I mentioned before, the NIH and NCI had in the early 2000s kind of built this momentum from bringing together these teams, and they really wanted to kind of leverage this and think about how this could be applied more broadly. And in 2006, they had this conference that was looking at the value of transdisciplinary teams. Really, what is it that makes kind of this special? In 2010, they had the first international team science conference that kind of grew out of this 2006 conference and submitted a white paper to the National Science Foundation on formalization of the science of team science. NSF had been funding teams before this, but putting a structure around it and really focusing on how do we make these teams perform to their best possible way was what this paper kind of really built out. Based on that, the NSF commissioned the National Academy of Sciences to do a report, and this is what came out in 2015, entitled "The Enhancing the Effectiveness of Team Science." And what this really did was set out a roadmap. So this was sort of a statement of intent to say, this is what we need to work on to make our teams more effective. It wasn't providing solutions, it was really kind of saying, this is what we recommend this field kind of examines. And that was when the science of team science formalized itself, institutionalization as kind of in 2018, this development of a professional body and saying, right, we've got the roadmap, we know where we need to go, we know what we need to find out. And that's where it's built from there. And so in 2018 and 2019, these two books essentially came out and started to address the issues highlighted in the 2015 National Academy's report roadmap. So what do we need to fix? Here's some of the research articles and chapters and findings that address some of that. And these two books, the NIH Field Guide for Collaboration in Team Science and the Strategies for Team Science Success, are what a lot of the sort of findings and discussion in this series are based upon. There are other places that we've kind of pulled from, but these are the two main places that we really lean on heavily in this series. So, the NIH Field Guide is great because it's 150 pages and it's a short, accessible read. So folks who are interested in team science, that would be the first thing I would point them to. The Strategies for Team Success handbook is a significantly longer and a more of a scientific read, but it's got some really fantastic resources in it. So this is a place where it'd be great for you to kind of pause the video for a second and take some notes. What is a team? Write down some ideas. What do you think a team is? This is, I would argue, this isn't a team. Just bringing people together and waiting for something to happen. You might be successful and it might form into a team, but it doesn't have any of the trappings of a team. It's just putting people in a room together and hoping for the best. I would argue the difference between a team and a group of individuals who are kind of roughly, maybe sort of going in the same direction is this idea of a shared vision, a set of roles and expectations, and this real kind of sense of trust and culture. And so you can have teams, and I've seen teams that look like a set of individuals who maybe don't communicate as much as they should, don't quite define their expectations, and they will look like this group on the left over here. But if you get a team together who have developed shared vision, who have an understanding of what each other are doing and work together, that's when you really start to get the benefits of teamwork. There are some technical definitions. These are from the literature. They are from more sort of business and industry focused literature rather than scientific ones, but it really highlights the interdependent nature of individuals. They share responsibility. They have defined outcomes. They have multiple information sources, so from different disciplines, but they have a centralized understanding and sharing mechanism. They have interdependencies, so it's not just people getting together and contributing stuff from themselves, but it's people working together on tasks that would otherwise be impossible without coordination. You have structure, you have a coordination, you have accountability, you have roles, you have valued goals, you have tasks, and you communicate intensively. You adapt, you have structure. So you can kind of see that there are frameworks around which a team is different to just people who occasionally meet together and tell each other what they're doing. And really leaning into some of that helps you make the most of a team situation rather than a group of individuals. Within team science, we have put a couple of labels around different spaces. So a unidisciplinary team is just those working within a single discipline. A multidisciplinary team is where multiple disciplines are together, but they are kind of looking at each other from different places. So you've got this single discipline in the middle, and you have folks from different disciplines who are kind of feeding into that, but you maybe don't have cross network interaction between the different disciplines. A cross-disciplinary team is where you do have that interaction. So instead of just looking at one discipline from different perspectives, you're sharing and you're starting to really question spaces between these different disciplines. In an interdisciplinary team, this is built out of the cross-disciplinary team, and you're really starting to get strong sharing. You're starting to look at what the different disciplines bring together. You're starting to really look at the intersectionality between the different disciplines and really sort of starting to synthesize new questions and ideas that just wouldn't have even been considered in any of the other kind of spaces. And then the real sort of goal in some ways is this transdisciplinarity. And that's where everyone's on the same page almost. You have a shared knowledge, you have a shared framework, you have a shared vocabulary, and you start to ask questions that just really above and beyond any of the disciplines. And this is where new fields arise. This is where new spaces are explored that just wouldn't even have been sort of talked about or discussed in any of the other spaces. So this is some of the vocabulary that we use in the science of team science. Linking back to IMOD, IMOD is not a team. We're not going to suggest that you are kind of responsible for the functioning and operating of IMOD in general. IMOD is, we call it a community. And so if you have an individual here, you have a sort of team that's come together here. This is IMOD, this big old mesh. And we call ourselves a community. The technical term would be a multi-team system. There are issues that come along with organizing and working in a multi-team system. There are now dynamics between teams, and we have collaborations that span team boundaries. That is a separate discussion and something we won't be touching an awful lot on in this series, but just kind of to set the stage, IMOD really is this multi-team system. And what we're focused on with the discussion is kind of this middle ground here, where you have a team somewhere between 6 to 8 individuals, is typically the size of these. We're going to talk a little bit more about this in a future place, but part of what we want to really think through is that we have task work. So that is very technical, very specific tasks, how to run a reaction, how to do a certain model, how to use a certain instrument. And then you have teamwork. And teamwork is separate to your technical training. Teamwork is really something that is transferable. So this is your attitude, your behavior, your logistical, your organizational pieces. And developing these skills will set you up to work in teams, whatever pathway you take, whether you become an academic or an industrial science, or whether you leave science research for something like consulting. These are the skills that will set you up to work comfortably, effectively, and perform well in teams of various sizes and various spaces. So that's what we're focusing on in this series. There's a great article from 2019 that looks at the characteristics of a translational scientist, and you will see this slide again. But the typical PhD or graduate experience looks at these two, I would argue. The rigorous researcher and the domain expert. That's starting to change, but you also need to be someone who's an effective communicator, someone who can think across different systems and across different boundaries, someone who's an innovator, a team player, a boundary crosser. And reading this article gives you great insight into what they mean by those different things and argues why a translational scientist is such an important feature. So I'd recommend that. We are going to refer to this in a couple of the different sessions. And again, just kind of an advert for this field guide. it's a really effective way of kind of getting yourself set up and prepared. Okay, that's the end of this section. I encourage you to look at the next section that is titled It Starts With You, but it's getting you prepared for working in teams and how you can set yourself up to really be an effective team player before you even join that team.